The James Webb Space Telescope, JWST, spotted something pretty cool, faint lights, like a city, coming from Proxima Centauri b. It's a planet that goes around a star in the closest star system to us, a little over 4 light-years away. This has people excited and wondering if we're the only ones out here. For years, scientists have wanted to find signs of alien life. Now, with the JWST's awesome infrared vision, it feels like we're getting closer. When the telescope looked at the dark side of Proxima Centauri b, it saw some bright flashes that didn't seem natural. These flashes looked similar to city lights on Earth as seen from space. These lights are interesting because they could mean there are smart beings over there. The weird thing is, the flashes are coming from areas that don't get any light from the star, so they might be artificial. One side of the planet is always in daylight, and the other is always dark. So, light on the dark side can't be from the star or just regular geology. This makes us wonder what kind of civilization could be there, how they make light, and how long they've been sending out these signals. David Kipping, an astronomer at Columbia University, thinks Proxima Centauri b is a strange planet. Usually, these kinds of planets soak up energy from their star and send it back as heat. But this one is acting differently. The energy it gives off doesn't seem like it's from normal heat processes, which could mean technology is involved. The JWST can spot these weird things because it's really good at seeing infrared light. It can peek into atmospheres and look at surfaces, even when there's no regular light. So, it can find stuff that might be from artificial energy, like patterned lights controlled by someone. The planet's temperature also depends on its star. Without an atmosphere, the sunny side would be super hot, and the dark side would be freezing. But if Proxima Centauri b has an atmosphere that moves heat around, then artificial lights on the dark side become even more of a deal. The JWST is already checking out the atmosphere to see if there are gases like methane, water vapor, carbon dioxide, and maybe ozone, which could point to life. The JWST can't directly find free oxygen, which is another sign of life, but it's great at reading the chemical makeup of the atmosphere when the planet passes in front of its star. It's also in a good spot to watch Proxima Centauri b as it orbits, so it can see how the planet changes, how hot it gets, and if there are any strange signals. If scientists can prove that these lights are real and not just random, and that they look like lights from an advanced power grid, it would be a huge discovery. But the JWST can only check out a few planets that are close by. That's why we need new tools coming soon. Giant telescopes on the ground, like the Extremely Large Telescope, ELT, should be able to study planets even better. These new telescopes and techniques will help us block out the bright light from stars so we can see the faint planets around them. Some technologies, like coronagraphs and star shades, will do just that. A coronagraph blocks the starlight inside the telescope, and a star shade is like a giant flower that floats in space to block the light before it even gets to the telescope. These tools could change the game for finding life, helping us study the atmospheres and surfaces of planets more clearly. As we get better at this, we might even be able to take pictures of alien worlds and study their weather, land, and maybe even signs of farms or factories. Future telescopes will also have adaptive optics to fix distortions caused by Earth's atmosphere, making our view sharper. This could let us map clouds, seasons, and surfaces of planets in amazing detail. Finding signs of life, like certain gases in the atmosphere, is super exciting. If we find methane and carbon dioxide in the right amounts, with ozone or water vapor, it could mean there's life. It's not a sure thing, but some combinations of gases could strongly suggest it. These new observations will tell us more about Proxima Centauri b and might show us similar things on other planets. As we learn about different planets and their atmospheres, we can better know what to look for when searching for life. Even though the JWST was made to study galaxies and the universe's history, it's become a key tool in the hunt for aliens. It's showing us things we never thought we could see, and maybe this light discovery is just the start. Researchers are already planning missions to build on the JWST's findings. Maybe we'll send probes or telescopes that can get better data or even send signals to these worlds. If we find out that the lights on Proxima Centauri b are artificial, it would change everything. It would mean we're not alone and that there are other smart beings out there, maybe older and wiser than us. This would change how we see life, civilization, and our place in the universe, and it would spark big talks about science, religion, and politics. But, even if the lights are natural, the discovery is still a big deal. It shows how powerful our telescopes have become and how well we can study other worlds. Some scientists are being careful and want more proof before saying anything definite, but others are getting excited. The JWST's data has given us a peek at potential alien activity, but it's also showing us what we don't know. Even if the lights on Proxima CentauriB aren't from aliens, they're making us think about new things. This is how science goes forward. We learn from being wrong just as much as from being right. The cool thing about this moment is that it opens doors for questions and more study. Astrobiology, the study of life in the universe, is growing quickly. With every planet we find in a good spot for life, and every time we spot water or organic molecules, the idea of life beyond Earth seems more real. The JWST is a powerful tool in this search. It can check planet atmospheres for carbon and find heat signatures that are different from what we'd expect from just rocks or stars. This ability to sniff out life from far away makes the JWST special. It can look into the core of planets and read their atmospheres like ancient texts. This is super important for planets like Proxima CentauriB. Red dwarf stars like Proxima Centauri are known for their strong flares and radiation, which can wipe out a planet's atmosphere. But if a planet has a strong magnetic field or a thick atmosphere that refills itself, it might survive. The JWST can test these ideas by looking at temperatures, checking greenhouse gases, and seeing how energy is absorbed and released. In other words, it can create a detailed picture of a distant world long before we send a probe there. The light from Proxima CentauriB takes over 4 years to reach us. That means what the JWST is seeing happened years ago. This makes us feel far away, not just in space but in time. If the city-like light is real, we're seeing it as it was when we were in a different stage of our lives. What's happening there now? Are the aliens, if they exist, still sending signals? Do they know we're watching them? These aren't just science fiction questions anymore. They're real scientific questions that come from real data. As our technology gets better, the idea of alien life becomes less of a daydream and more of something we can test. Missions like Breakthrough Starshot are figuring out how to send tiny probes to nearby star systems, including Proxima Centauri, within our lifetime. These probes could beam back pictures of planets and maybe even civilizations. This would be the first step toward really exploring other stars, not just in books but for real. The JWST's data will help us decide where to send these future explorers. Meanwhile, people around the world are working together to keep an eye on the JWST's findings. No one telescope can prove aliens exist. It will take a bunch of tools, observations, and scientists from different fields working together to get the whole story. Ground-based observatories, like the European Southern Observatory, and upcoming facilities, like the 30-meter telescope, TMT, and the Giant Magellan Telescope, GMT, will join in. Radio telescopes will listen for signals, and future space telescopes will offer broader views and better imaging. Together, they'll give us a detailed picture of alien worlds. Even if we don't find life, the JWST's observations have big ideas behind them. The fact that we might have found signs of another civilization makes us think about who we are as humans. What should we do as smart beings in a universe that might be full of others? What if we're not alone, but we're not the first or the most advanced? These questions echo through science, ethics, politics, and religion. They remind us that the universe is not just a place, but something we share, where many stories might be happening at once. We also tend to see what we want to see. When we see lights, we think of cities. When we see energy patterns, we think of factories or messages. But alien life might be very different from what we expect. Their cities might not shine with regular lights, their messages might not be in radio waves, and their bodies might be based on elements that are strange to us.